It's time to get in shape. Today I am going over the shapes of molecules for your A-level chemistry exam. We've got quite a bit to cover, so let's dive in. A lot of this episode is going to focus on VSEPR theory. Now, that is valence shell electron pair repulsion theory. VSEPR. So when you hear me say VSEPR, that's what I'm talking about. To understand what this is, we need to talk about charge clouds. Now, electrons occupy orbitals, but what is an orbital? An orbital is just a region of space where you are likely to find an electron. The usual definition is that an orbital is a region of space where there is a 95% charge the electron is located. This means you can view electrons not as particles, but as charged clouds, regions of space where electrons move around. Next, we need to talk about repulsions. Now, electrons are negatively charged. This means they will repel each other. Electrons will try and stay as far away from each other as possible. This repulsion is what determines the geometry of a molecule. The electrons in the bonds repel and try to stay as far away from each other as possible. Electrons hate each other. They are not friends, okay? They are Regina George and Katie Harron in like the third section of Mean Girls. They're not talking. They repel each other. Now we need to differentiate between lone pairs and bonding pairs. It's a really important detail. Lone pairs are held closer to the nucleus of an atom. This means they repel each other more as they are physically closer. The trend in repulsion strength of most repulsion to least is lone pair to lone pair, then lone pair to bonding pair, and bonding pair to bonding pair. So the key thing to take away from that is that lone pair of electrons repel more than bonding pairs of electrons. So two types of electron pairs, lone pairs repel more. And remember to think of orbitals as a cute little charge cloud, a region of space where you are 95% likely to find an electron. I wonder what that other 5% is called. I don't want to know. It sounds scary. Now, for this unit, you need to know a lot of different shapes. So let's dive in. There is an optimal geometry for every number of electron pairs. So the different types of geometries you need to know are linear. If the central atom of a molecule has two electron pairs, it will likely adopt a linear geometry, and the bond angle will be 180 degrees. So a good example is CO2. Trigonal planar. If the central atom of a molecule has three electron pairs, it will likely adopt a trigonal planar geometry. Getting my subject confused. And the bond angle will be 120 degrees. So an example is BF3. We've got three bonded pairs surrounding that central B atom, so the molecule is going to adopt a trigonal planar geometry. Next, we have tetrahedral. If the atom of a molecule has four electron pairs surrounding it, it will likely adopt a tetrahedral geometry. And here the bond angle is 109.5. Next, we have trigonal bipyramidal. And here, if the central atom of a molecule has five electron pairs, it will likely adopt a trigonal bipyramidal geometry. Molecules within this shape have two bond angles, so 120 degrees around the equator and a 90-degree angle from the equator to the apex. So let's run through those again. We have linear. This is the geometry adopted by molecules with two electron pairs around the central atom. Trigonal bipyramidal is when we have five electron pairs around the central atom. Trigonal planar is three electron pairs. Tetrahedral is four electron pairs. And there's one more we're going to chuck in. Octahedral. Octahedral is if the central atom of a molecule has six electron pairs, it will likely adopt an octahedral geometry, and the bond angle will be 90 degrees. An example is SCl6. So those are the different geometries you need to know. I know what you're thinking, that's a lot to take in. Just keep reading over it, just keep consolidating it will stick, I promise. Just think about the electrons, how many electron pairs there are around that central atom, and it's easy breezy beautiful. It's easy. Don't you worry about it. Let's recap that strength of repulsion. Do we remember the strongest repulsion we get from electrons? That's when we have a lone pair next to a lone pair. That's the strongest repulsion. Then it's bonding pair to bonding pair, and then it's lone pair to bonding pair, and then finally it's bonding pair to bonding pair. So whenever there's a lone pair, there is more repulsion. I'm going to quiz you on some bond angles now. What's linear? Linear is 180 degrees. What about tetrahedral? That is 109.5. Do you remember octahedral? That's 90. That's 90. So if a central atom of a molecule has 5 electron pairs, what geometry are we talking? We're talking trigonal bipyramidal. And one more question to finish. If a molecule has 4 electron pairs around its central atom, what's its geometry going to be? It's going to be tetrahedral. So 4 electron pairs, we get a tetrahedral geometry. Now that brings us to the end of this episode. I hope it was a useful run through of molecular geometry, and we even did a little bit of Vesper theory. So lucky you. Good luck with your revision, and I look forward to joining you on the next episode.